Hey guys, it's Kendra, and I'm going to be solving quadratic equations and solving for their roots. You're doing it with me. So let me kind of teach you the swing of things. So right on this right-hand side, we kind of have like an example with variables. And even though this kind of looks complicated, that's why I'm going to have this super straightforward example to also go along with this. We even have some of these sign properties here to remember when we're tackling the actual diamond aspect, which is going to be key to understanding this process. So we're first going to start off with making a window pane. I'm going to actually do this in red because this is one of the most important parts. It actually should be called the window pane diamond method, but you know what, whatever. So we have this. We are just going to create our little 4 quadrants right here. And we have x squared plus 6x plus 9 equals 0. This is perfect to begin with because there's 0 on one side, which is always what we need. It doesn't matter which side, but as long as it's equal to 0. That's key. So even if you need to simplify, please do that first. In this case, we don't have to, so let's look at this in its whole. So we have x squared. We can put that in the top left-hand corner. And in the bottom right-hand corner, we have 9. We're actually going to multiply these two to get our diamond form. In the top part of the diamond, we're going to show this product. So 9x squared, that's the product. Now for the bottom part, we are actually going to put 6x here. Now that we filled out half of this diamond, we can actually start solving for the other sides in both of these cases. So we're trying to find something that adds to be 6x. We're also looking for the same two numbers that multiply to get 9x squared. And that's kind of what you see in this demonstration here, but it's kind of hard to understand, so this is why we're doing this. With this, we're going to find first a common factor between 9 and 6, which will be, probably the lowest will be 3. So we're going to take 3, we're going to create that diamond shape, but since I don't want it to get all messy, I'll just keep it the way it is. But the common factor would be 3, so we're just going to start very slow and easy. 3 times 1 equals 3, so we already know that the product is not the same as 9. So that also doesn't work. Let's do 3 times 2, which equals 6, which doesn't equal a product of 9, so that's wrong as well. 3 times 3, though, does indeed equal 9. But we do have to double check to make sure that 3 plus 3 also equals 6, and which it does. This is our answer. So we have these two numbers right here, 3 and 3. We're going to fill that in, 3 and 3. We also know that based on these two numbers, them being positive, is that these two numbers have to be positive together, because a positive times a positive is a positive, but if you add them together, they also have to be positive, which is 6x. So in that case as well, we also know that this has to have an x and another x. Good to have x's. So we're going to actually fill this out right here too, with the same information. So now we can use the corners of these, the closest corners actually, even though I messed it up. We're going to use the closest corners to finally solve for the simplified version of this equation. So in this case, what equals x squared? You're right, x times x. Now that we look at the 3x, we already have an x right here. What do we need to get 3x? A 3. Now down here we have 3x again. We just know it needs 3 because we're looking at the closest corners. No diagonal, just straight across for the corners, in case that confuses you. So in this case, we can also tell that this is true because 3 times 3 does equal 9, which is in our bottom right-hand corner. So we know that checks out. We will then simplify this to put in parentheses x plus 3 in parentheses times x plus 3 in parentheses equals 0. We can even distribute and solve for this to get the same equation that is up here, but this way is way simpler to use. And if you have an equation like this, you can straightforward just solve it as you would using this. So you're just going to solve for x separately, but since these two have the same number, we're just going to go for it. We're going to subtract 3, get x on one side, x equals negative 3. So in this case, we know our parabola is going to look like this, of course, because that is the graph of a quadratic equation, parabola. But also, since we have one number, one common number, because if we solve for this one too, it will of course be the same, x equals -3, we do know that this is going to be at the vertex because they are the same number. This will be different. In most cases, we will have two separate roots where it will look the same, but there will be a and there will be b, rather than just one at the vertex. So we also know that this is definitely going to be equal to 0 for the y, so we can just put -3, 0 as the vertex, and these we would solve for the same. They should both equal to 0 if they are different numbers still. So using this, we're able to identify the roots, and I hope that's a pretty simple way to explain it, but I also hope that if you guys have any more concerns, you will leave them in the comments, and I'm actually going to do a video next on the actual quadratic formula, which is way superior and way easier to use, really, especially when given roots that will have a decimal or a fraction of sorts. That's when that is necessary to use. But in this case, it's very fast-paced and straightforward, so thank you guys for watching, and I hope that you guys can take something away from this.